All right. So this podcast is meant to address one of the most difficult skills that you might have to encounter when naming compounds. When you're naming compounds, it's very important to be specific about what you're doing. When it comes to molecular compounds, you need to make sure you add prefixes. So when you are naming ionic compounds, it's generally as easy as just naming the ions. Now, when that becomes difficult is A, when you have transition metals, and B, when you have polyatomic ions. Now, the polyatomic ions for us will be pretty easy. You'll have a list of common ions, you'll have a list of the formulas and the charges of those ions, and before too long, you're going to get used to them to the point where you don't even need to look them up. But you'll have that resource if you need it. Transition metals can be a little harder, because what we have to do when we're naming compounds that contain transition metals is we have to include a Roman numeral. And that Roman numeral, as we've talked about in class a few times, tells you the charge or the oxidation number on that ion. And that charge may vary depending on what else is involved in the compound. So let's take an example. Let's take an example of CuCl2. So this is a pretty common compound. It has a lot of applications, and it's going to be pretty easy for us to figure out what the charge is going to be based on what we already know. Now, what we already know is the charge on the chloride ion. Now, chlorine being in group 7A, being a halogen, all of those ions will have a charge of -1. So, if we take the charge of -1 and we multiply by the number of ions, which of course is 2, we have a total negative charge of -2 on the right side. So, what we need to figure out is what the charge on copper would have to be to make the total charge on the entire compound 0. And of course, what plus -2 gives you 0? It's +2. So, we know that this compound will be named copper chloride. Now, we need to be able to tell this apart from another copper chloride compound that we might encounter. So, to make sure we know, we're going to add that Roman numeral in there, and it's going to be copper 2 chloride. So, what you need to do basically is you need to make sure that you add up the charges on the negative ion, which you're always going to know because you're always going to be able to look them up. Either it's going to be a single monatomic ion that you're going to know the charge of from the periodic table, or you're going to look it up on the common ion chart, and then you need to make the other side match up. So let me get rid of this, and we'll try one more example. And this one might be a little more difficult because you might have noticed a shortcut that you're not necessarily going to be able to get away with here. So let's try vanadium and phosphorus. So we have this compound here. Now, if you look on your common ion chart, you'll realize that the negative ion here is called phosphate. So we can write that down because we know that that's not going to change. Now, we also know that the charge on phosphate is -3. So if we have 5 of those ions and each one has a charge of -3, we know that the total negative charge is -15. Pretty big number, but nothing we can't handle. So now we have to go to the other side, and we need to make sure that all of the charges add up to 0. And the way we're going to do that is we're going to make sure that this side adds up to 15. Now, we know that all 3 of those vanadium ions that we have to add up to 15. So if 3 of them equal 15, we divide by 3 to figure out what the charge on one of them will be. And of course, it's going to be +5. So, our final answer for the name of this compound is going to be vanadium 5, and V is the Roman numeral for 5, phosphate. So vanadium 5 phosphate would be the full name of that compound. I apologize for the messiness. My finger doesn't draw very well, but that should give you an idea of how to insert Roman numerals into the names of compounds. Hope that helps. Bye-bye.